been a while since we saw a table like this, and I'm going to go ahead and just kind of show the table step by step. So I'm going to start by just kind of copying the table down. And I think it'll be worth it for you to just take this step of doing this, because I think for you to be able to just reference this will make the next two practice problems like a little bit easier. So right now I'm just copying. Okay, and then what I'm going to do is I'm going to show work like this is A, B, C, D, and I'm just doing this so I can show work below and you can know like which square the work belongs to. Okay, so like for square A, what it's saying is, hey, x is 0. So if f of x is 5x minus 9, what does that equal? So what that looks like is this. It's you're plugging in 0 for x. So notice I put the 0 where the x is, and this is not multiplication, right? That's like a common error to think that this is multiplication. This is just like a funny, weird way that mathematicians decide to write this. It's called f of x. It means if I plug 0 into this function called f, what do I get? And we can see 5 times 0 is 0, minus 9 is negative 9. So in this part of the table, you'd put negative 9. Right, so I did the work for A right here, see? All right, I'm going to do the work for box number B right here. This is a different function, 5 to the power of x. So this time, I'm doing 5 to the power of x, and I'm plugging in 0 for x. So it's 5 to the power of 0. What is 5 to the power of 0? It's 1, okay? And this is just something, hopefully you remember. Any number to the power of 0 equals 1. Any number. So I could do 100 to the power of 0, it equals 1. I could do 3.4 to the power of 0, it equals 1. It doesn't matter. Any number to the power of 0 equals 1. Ooh, that's ugly. Let's make that a little bigger. Okay, so if I have any number to the 0 power, it equals 1. Okay, so in this case, I would put 1 in this box. Okay, let's keep going. So for box C, I'm taking this function, 5x minus 9, and I'm plugging in 1. I'm plugging in 1 for x. So what do I get? 5 times 1 is 5, minus 9 is negative 4. So I would put negative 4 in this box. Okay, over here, D, I'm plugging 1 into this x. So it's 5 to the power of x. I'm going to make it 5 to the power of 1. What is 5 to the power of 1? It's 5. Okay, and this is another thing that we just need to remember about exponents. Any number to the power of 1 equals itself. Right, so like 10 to the power of 1 equals 10. 7 to the power of 1 equals 7. 5 to the power of 1 equals 5. Oh, sorry. Equals 5. Okay, so this would be 5. Okay, box E. I'm now plugging in a slightly bigger number. I'm plugging in 3, but it's the same idea. 5 times 3 is 15, minus 9, and I get 6. Right, 5 minus 9 is 6, so I'm going to put 6 right here. And then here, I'm plugging in, this is box F, I'm plugging in 3 into 5 to the x. So 5 to the power of x, I'm plugging in 3 for x. So what does this mean? This means 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. Okay, so I would plug in 125 here. Okay, now this last one's a little bit tricky. Here, I'm not given the x, but I'm told, well, when I plug in x, some mystery number, I get 1. And when I plug in that same mystery x, I get 25. Okay, so here's what that means. And what you might find is that sometimes it's easier to solve one, sometimes it's easier to solve the other. But what this means, right, and I'm just going to recopy the equation so you can really see what I'm doing here. Before I was plugging in here, I was plugging in for x. Okay, but now I'm saying, oh, well, I already know what f of x equals. I already know what I get, and so it's 1, so I'm going to put it here. Okay, and over here, I'm going to just plug into the other equation. I'm still just working on that one box, but this is saying there's some mystery x, And when I plug into this equation, when I plug that mystery x into that equation, it equals 25. So you can actually solve either of these equations. You can say, 5 to what power equals 25? And you might just come up with 5 to what power equals 25, right? Which is great. This one is kind of always going to be an equation that you can just solve. Like, oh, okay, well, I'm going to get x by itself, so I'm going to add 9 to both sides. And I'm going to divide by 5. And I get 2 equals x. And then you ask yourself, okay, does 5 to the second power equal x? Is this true? Yeah, 5 times 5 is 25. So then you know your answer is correct, and you can go ahead and put your 2 right here.